Welcome. In this tutorial we are going to learn about how to intercept attribute access. So first we will begin with intercepting attribute access using magic, dunder or the special methods. It is called dunder method, which is a short form of double underscore method name double underscore. For example, get attribute method is a special method which begins with double underscore, then its name, and it ends with double underscore. So in short, it is called as a dunder get attribute. Now get attribute is invoked when you access any attribute of a class, and it returns the value of that attribute if the particular attribute with given name is found. Set attribute is invoked when setting any attribute to the class or the object, and delete attribute is invoked when deleting any attribute of a class or a object. Now last method is a get attribute, ATTR. It is a fallback method for get attribute method. It is invoked when there are no attribute with the given name is found using get attribute method, and it is generally used for derived attribute such as age, which can be derived from the date of birth. And get ATTR method is only invoked when get attribute method fails to find matching attribute, and it must raise attribute error in case of any unknown attribute is accessed. Now before moving to the example, we need to understand some basic concept. So object class is implicitly inherited by all classes, and it provides default implementation for many dunders. For example, for intercepting attribute access, object class provide default implementation for get attribute, set attribute, delete attribute. So whenever you are accessing attributes, it is invoked the default implementation of object class. Now when we are modifying those implementation, we are overriding those methods in our user defined class, and in those user defined class, in order to access that particular default implementation, we need to access it using class object class dot the method name and the parameter which is passed to that particular method. We need to pass it here to the object class. So instead of referring to the self, we need to access attribute using object class. Otherwise, it will result in recursion error. So it will say like maximum recursion depth is reached, because you are trying to access the current object using current object, so it will wound up in recursion infinitely. So here is the example. Here we have created a bank account class, and we are overriding get attribute, set attribute and delete attribute method. And inside this method, we are accessing object class original implementation by just passing the parameter passed to this method. And in order to know that we are calling this method, we are printing the message that we are calling this method. Now if we create object of this class and access any attribute, get attribute or modify the attribute or delete attribute, it will invoke this method, and whatever the attribute access is raised, it will pass those attribute access to the original object class implementation. So let's execute it. So here we have created the bank account object. Obviously we have passed the parameter account number, so it will set the value to the instance. So set method is called here. Now if we access any attribute of class, it will call getAttribute method. So getAttribute method is called here. Now if we modify it, as we can see, the setAttribute method is called. And if we try to delete any attribute, deleteAttribute method is called. Now, in order to access attribute programmatically inside the class or outside the class, Python provides methods for it. So for getAttribute, there is a getattr method which can be invoked passing the object inside it in order to access attribute, modify the attribute value, or to delete attribute. And it will invoke the same functions as we saw for the intercepting attribute access. So for the same class, we will create another object and we will access, modify or delete attribute using this method. Okay. So first we will get attribute using getattr method. So as we can see, it is invoking the same function getAttribute and printing this message, getting this attribute. Now it has one extra parameter which takes a default value if it is given and the given attribute name is not found on the object, it returns this default value. So we know from the class definition, it does not have undefined attribute inside the class definition. So it will not found this attribute. So it should return this value. So as we can see, it is trying to get the given attribute name, but it does not find any attribute, so it is returning the default value passed to the getattr method. Next is setAttribute method. In order to modify the value of a particular attribute, first we need to pass object, then attribute name and new value. So as we can see here, the attribute value before and after modification. So the given value is set to the attribute of a given object. And last is deleteAttribute, which will delete the given attribute of a class. These methods are useful when you are referring any attribute inside the class, because you cannot directly access a dynamic attribute name using self dot any variable name. So in order to access the dynamic attribute name, you need to invoke this method in which you can pass the attribute name as a string. Now let's see another example which uses getattr method, which is used for derived attribute. So here we have defined an attribute access for a derived attribute age, which will be derived from the date of birth. So in this class definition of bank account, there is no attribute called age. So when requesting this attribute, the getAttribute method will not find any attribute having name age. So it will pass that attribute access to getattr method, which is a fallback method for getAttribute method. And here we are checking that if the given attribute name is age, then we are calculating the age and returning the age. Or else if the unknown attribute is accessed, we are raising attribute error, which will show that this attribute is not defined or not found. And for getAttribute, in order to access this getattr, we need to invoke getattr method of object class with the given name if we don't find the attribute which is requested. Okay, so earlier we saw a data attribute access. Same way, the attribute access for the method attribute can also be intercepted using getAttribute method. So we can also check the attribute access for the methods of the class also here. So whenever the method is invoked, the getAttribute method will intercept that call. So here we are passing that call to the object.getAttribute method for the default implementation. So it will return that particular method to the caller, and that particular method can be invoked. So in this case, if the data attribute is not found for the given name, then it will check for the method attribute. Even the method attribute is not found, then it will go for the fallback method of getAttribute implementation of object class. Okay, now let's create object of this bank account. So here it is constructed and the given parameters are set to the object. Now first we will get the attribute of it. So it is printing getting attribute and it is returning the attribute value. Same way we can set the attribute. It will invoke the setattr method of a class, which will print this message, and when accessing the any function of a class, it will also print the message that getting attribute amount, because this particular method is accessing the data attribute in which we have set the print function here for the get attribute. And for set attribute also we have printing the message. So same way, if we can print the message for accessing the methods of a class. So if we print the method name, it will show whenever we are accessing the method. So let's again create the attribute of object of class and access the method. So here, as we can see, we have intercepted access for the method attribute also. Same for the other method, withdraw. So whenever any method attribute is accessed or method is invoked, that call is intercepted by our special Dunder method. Now we will access the derived attribute age. So as we can see here, it is returning the age from the date of birth. So if we check the implementation, here it is printing get attribute dob. So it is in here. It does not find any matching attribute, so it comes here and it is calculating the age and it is returning the calculated age. So this is how you can intercept attribute access using special methods. Now we will see topic is property. So it allows intercepting attributes access on per attribute wise. So earlier we saw Dunder, which was intercepting attribute access for each and every attribute, either method or the data attribute. Now if you want to track any particular data attribute, then we can do it using property function. So property acts as a proxy around the variable or the data attribute for setting, getting and deleting a particular attribute. And setting a property around any attribute does not make it as a private. That attribute can still directly access via object of a class, or the if it is a class variable, then it is accessible using class. So now we will take a look at the property constructor. So this is the constructor for the property. It takes 4 argument: getter, setter and delete method, same as we saw earlier for the Dunder. So for a single particular attribute, we can configure getter, setter and delete method. And last parameter is docstring, which is a documentation for that particular property. Now, not all these parameters are mandatory. So in order to block access to setting particular attribute or deleting attribute, you need to pass none as a parameter. So if you want to create a read-only property, then you pass only getter method, which will return the particular value of a attribute, and set none to this 2 parameters, which will block the access for modifying or deleting the attribute, and it will raise the error automatically. And if you pass none for all these 3 parameters, it will raise error, because then property does not make any sense if you are not providing any method for intercepting the attribute access. So let's define the property. So here we are having one pseudo private attribute is amount, and we want to provide or intercept the attribute access for this pseudo private attribute using property. So we have created getter, setter and delete method, which gets, set and delete the attribute, and we have passed those methods inside the property method. And last one is a documentation string for this. So new property named amount will be created as an amount, and using amount we can access this pseudo private attribute, because this getter, setter and delete method is using that particular pseudo private attribute here. Now property is defined as a class level variable, so it is defined inside the class. So let's construct the object of a class. Now if we check for the dictionary of a class, as we can see, the pseudo private attribute name is name mangled with the name of the class, and it is having the value passed to the constructor. Now we will try to access this attribute using our property amount. Okay, so first we will modify the amount. So as we can see, when setting the amount, it is printing setting amount, which is the message we have printed on the setter method. So this attribute access is intercepted by the property, and it is returning the value of a, or it is setting the value to the pseudo private attribute. So again, if we check the dictionary, as we can see here, this attribute value is modified. Same way we can access the value, so it will return the value, and it is printing this message as we configured for the getter method. And if we try to delete, it will print the delete message and delete the pseudo private attribute, as it is configured inside this delete method for the given property. And in order to see the documentation or the doc string passed to the property constructor in PyCharm, just place the cursor to the property and press Ctrl+Q. So it will fetch the documentation string set for that particular property. Next, we will create read-only property. So if we only provide the getter method to the class and pass none for the setter and deleter method, then that property acts as a read-only property. Now we will create an object of read-only property class. So if you try to fetch the attribute, it will print the getting amount, which is printed by the getter method of a property. But if you try to modify or delete the value, it will say attribute can be set and attribute can be deleted, because we have created this property as a read-only property. Next is using property for the derived attribute. So earlier we saw get ATTR Dunder, which was returning the derived attribute value. So same can be done using the property also. So if we have a value or the attribute which we want to be accessed as a derived attribute, we will define a get method or the getter method for that particular derived attribute and pass it to the property, and pass none for the setter and deleter method. And here we are returning the age of the person from its date of the birth passed. So let's create an object of that class and access the derived attribute. As you can see, it is printing this message of the getter method, and it is printing the calculated age, which is a derived attribute. Next topic is property using decorator. So earlier we saw property function in which we are passing the getter, setter and deleter method. So same method can be configured using decorator. So for that, defining property @property decorator is used. So it is tagged on a getter method, which will create the property name with the name of the given getter method, and for that getter method name, use that getter method name dot setter on the setter method of the property, and same the getter method's name dot deleter on the delete method. So let's see it with example. Here we want to set a property named amount for this pseudo private attribute amount. So we will define a method, in an instance method with the name of property, which we want to expose as a property of a given pseudo private variable. So we want to access this amount as a amount. So we have named this instance method as a amount and define @property decorator to it. Now this has created amount property. Now for the setter method, use the name of this getter method's name @amount and dot setter, which sets the amount pseudo private variable, and same for the deleter, the name of this method name of this method dot deleter, which will define the deleter method for this property. So let's create an instance of this class and let's see the attribute access in action. Now in order to set docstring here, we can provide docstring inside the getter method of a, or the first property method of a class, so which defines this name as a property. So let's create instance of the class. Now let's set the or modify the amount property. So as we can see, it is invoking the setter method of a property amount. So as we can see here, the attribute access of amount is intercepted by the property configured using @property decorator. Same way, if we try to access the documentation, it is visible here. And if we try to get, it is printing the message which we have placed inside the getter method. And if we invoke delete, it is printing that delete method placed inside the deleter method of a property. So @property decorator defines the property with the given name of the getter method, which is defined after this @property decorator. In using the same name of this method, you can define setter and deleter method. Now you can define these methods of setter and getter and deleter method outside of a class also. So as we can see, if you are defining getter, setter and deleter method for each an attribute, if you are providing a different attribute interception, then your class definition will become bulky and you are including the code which are not or the less important, and which is not your main business logic. So you can shift this code outside the class. So we will see how to define this method outside of the class. So here we have defined one function which contains this setter and getter method, and this function is called to create property. So this is a function and it can also be replaced with the class. So in class also you can define this getter and setter function which returns a property on the call of this function here. So this way we have modularized the setting of this property function. So now let's create an instance of this class. So as we can see, while creating the instance, it is setting this name. So it is invoking the getAttribute method. This method which is set to this property, and this property attribute or the property object is written on the call of this method. So same way, if you are accessing attribute on object of the class, it will print or it will invoke the getter method. Same way, if you are deleting, it will invoke that delete method. So here we have set deleter method to none. That's why it is printing that you cannot delete the attribute. Next is defining custom property function. Now in this example, we will define a property function or the function which returns the object of property which is configured for the specific purpose. So here we have defined a function which sets a numeric data of given particular length. So when setting the attribute value, it will check the type of value it is passed. Then if the given value is not as per the given required length of the attribute, then it raises the attribute or the value error. It is raising value error here, and it is also converting if the value of a valid length is given as a string. So it is internally converting that given string value into the integer value. So mainly this setter method will try to maintain the required length of the value in integer, and it allows value to be passed as a string. So it will convert internally that string into the integer value. So this setter property or the custom setter function is set in the property constructor setter method. Okay, and this function is used inside our class person, which is set on the attribute phone number. So it requires length of 10. So any digit less than or the greater than 10 will raise value error. So let's define the object of this person class. So for each attribute, we have defined the property. So for the other function, we have used this auto property function, which defines the getter and setter function. So that's why all the attributes of a given class is intercepted using property. So if we try to access each attribute, it will invoke their getter property method. Now we will set the phone number using string of length 10. Now let's see it converts to the integer and set it to the given property attribute. Now we will check. So it is not raising any error. Now if we check phone number, the new phone number is set as per the given string. And if we check the type of phone number, it is integer. So it is internally converting that string object into the integer. Now if you are passing any invalid value such as length, which is less than the given length, then it will raise error. And if you are passing the length greater than 10, then also it is raising error. And if you are passing any invalid value also, then also we have put the checking of the value here, that if the type is not integer or the string, then it is raising value error. So this way you can customize the setting of attribute of for a particular type, or you can allow multiple type to be set and internally convert those types of value into the one single type. So same way, the property decorator can also be used as a for the derived attribute. So you just need to define @property decorator for the given getter method of a derived attribute. So here we want to expose age as a derived attribute. So we have marked that age instance method as a derived as a property, and it is returning the age. So if we check, it is returning age from the derived attribute. For the derived attribute age, it is returning from the person's date of birth. Next topic is descriptors. Descriptor is an object attribute whose attribute access methods are overridden by the methods of descriptor protocol. So descriptor protocols defines three methods: get, set, and delete method. Any class implementing one of this method is called as a descriptor class. And descriptor is a fundamental way to intercept attribute access, which is used by the other functionalities such as property, slots, decorators such as static method, class method, and even for the super function. So earlier we saw a property function. So for that property function, the underlying attribute access is intercepted using descriptors. So internally, property function uses these methods to intercept attribute access. So now we will understand the parameters of this get, set and delete function. So first parameter is a self, which is an instance of a descriptor class which is attached to the target class. So earlier we saw that we were invoking property function to set that particular attribute as a property. So same way, that attribute for the descriptor will be set, and that object is passed as a self. Instance is a instance of a or the object of a target class on which the attribute access is performed. And third one is a owner. Owner is a target class of an instance. This instance, which is passed as a second parameter on which the operation is performed. We will see in details what are the parameters passed for the descriptor with an example. So there are two types of descriptor based on how you define or which method you define in the class. So if you are defining setattr method, set method or delete method, it is called as a data descriptor. And if you are only defining get method, then it is called as a non-data descriptor or the method descriptor, because method of a class only defines the get method. So let's first define this Dunders and print what are the attributes is passed to this method when accessing any attribute. So here we have defined the descriptor class. This class is defining get, set and delete method. So it is a data descriptor class, and in this get, set and delete method we are just printing, we are doing nothing but printing this value of the parameter which is passed to it. And we have defining this descriptor for the name attribute. So first we will create the attribute of a person class which uses our descriptor. So obviously it will set this parameter. So on the setter method, as we can see, self is passed as an object of a descriptor which is set on the name. So this object is assigned to the name, so that object is passed as a first argument of a setter function or the self argument which is passed to the all of these functions. Second one is an instance. So that is the instance of a person 1 on which we have invoked the attribute access. So this is the object, and because it is a setter function, it takes the value of the attribute. So value of the attribute is passed, it is intercepted by it. Now for the getter function, if we invoke, as we can see, first two argument is the same. Self is a object of a descriptor class, and instance is the instance on which the attribute access is invoked, and owner of the class is the class name or the class of which the instance is created. So this is the person 1 is the class of which the instance is created, and instance is the instance on which the attribute is accessed, and self is the property instance. So object of that property class on which the access is raised. So now that we know these parameters, we can modify or define getter, setter and delete method for the particular attribute using descriptor. So let's create a descriptor which modifies the or intercepts the attribute access. So here, as you can see, the name attribute is defined as a descriptor, and this is a data descriptor class because it overrides or it defines the get and set method of descriptor protocol. So in this getter and setter method, we are printing this getting and setting attribute method, and when getting or setting this given attribute name, we are modifying the instance dictionary. So instance, we know earlier we saw the whatever the instance on which we are invoking this attribute access is passed as an instance argument, which is a second argument. So on that particular instance, we are modifying that instance dictionary which contains the instance attributes with the given name which is passed when creating an object of the descriptor here. So when this class definition is created, this constructor will create an object of this descriptor class which will set the given attribute name as an attribute name. So when you are getting or setting this attribute, that attribute will be accessed for this name attribute or set on the instance. So you are exposing the person name descriptor as an instance attribute, and that descriptor wraps around access on the attribute this underscore name. So let's create object of this person class and intercept this attribute access using the descriptor name. So we'll create two persons. So we'll make sure that we are modifying the instance attribute. First we will get the value of both of these instance. So p1.name and p2.name both are having different value which is fetched from the name attribute invoked on a descriptor object. So if we check the dictionary, it contains the underscore name, and that particular attribute is accessed using the name descriptor. Now we will change the value of a person. So person name is modified here. So it is printing the setter methods message, and after setting it, if you are fetching again the value of the person, then it is giving the new value of the person. Now let's introspect the descriptor object and the class which uses the descriptor. So first we will see the class, what it contains. So if we check the dictionary keys, as we can see here, the name is defined as a class attribute which is a descriptor object, and if we are checking the instance of the class, it contains only the underscore name attribute which is defined inside the init method. So init method is bounding this instance variable to it that only is visible to it. So whenever we are invoking this descriptor, it is returning or modifying the value of that particular instance variable. Now using the class dictionary, we will access the name, which should return the descriptor object. So as we can see, it is returning the descriptor. And if we see the dictionary keys for the descriptor, it contains this value as we set it in the init method of the descriptor class. Now in order to invoke the getter setter method of a descriptor, you can traverse through the class using this, like %2, we are extracting the descriptor object from the dictionary of a class. Then on that dictionary object, we are invoking get method by manually passing the instance of a class and the owner of a class. So if we invoke it, it will fetch the value of a particular attribute, which is the same as this. Now next is read-only descriptor. If the set method of descriptor does not allow modification to the attribute value, that particular descriptor becomes a read-only descriptor. So for this example, here account number is a descriptor, data descriptor, and it contains set and delete method which raises the attribute error. So after creating account number, if you are accessing using account number and if you try to modify it, it will raise attribute error. But you can still modify your account number or this attribute by directly accessing using this name. Only the descriptor which you are exposing with the given name this is read-only. So let's create object of this class and access the attribute value. So it is returning the account number for both of these. And if we try to access or if we try to modify those value using the descriptor attribute, it will raise attribute error saying that it is a read-only attribute. But the attribute which you defined using init method, account number, can still be modified. So this way we have modified this account number, and if we try to access this using property, it will return the newly modified value. Next topic is non-data descriptors or the method descriptors. So if your descriptor class only defines the get method, then it is considered as a non-data descriptor. So it can be defined for instance method, class method, and static method. So let's begin with defining non-data descriptor for the instance method. So this is the instance method descriptor class which only defines the get method, which prints the invoking message, and it defines a function or the inner function which gets the arguments and keyword arguments passed to it and invoke that function on the function with the on the instance. So same instance is passed here. So this function will be invoked on the instance with the given keyword argument, and that function is returned when you are getting it. So you are returning a function call with the argument set to it, and when you are calling from the instance, it is invoked, and whatever the logic defined in the function when you are defining the descriptor will be invoked. So when you are getting it, you are passing the parameter, or when you are invoking this function, we will see with the example, you pass this parameter, that parameter is intercepted here, and original function parameter is set here and invoked here using the instance passed as a self. So now this is set for the instance method, so that this non-data descriptor can be used to wrap the instance method. We have, for the person, we have get full name as a instance method, which can be used as a non-data descriptor for the instance method. So we have wrapped this get full name inside our instance method descriptor class. So that function is stored inside the function attribute, and whenever this function is called, this get method will be invoked passing this parameter, and the inner function will get the whatever the argument is passed, and that call, the stored function is getted here using self dot function, and using this instance and the given parameter, the particular function is invoked and the value is returned. So let's see with the example in action. So here the person object is created, and we are invoking get full name method, which is defined as a descriptor. So let's invoke it. So it is printing, invoking the function name function. So get full name is invoked, and the value or the business logic written inside is executed, and its value is returned. So this way attribute access to the instance method can be intercepted. So instance methods argument you can capture, you can validate those argument, you can type check on those argument, or you can check the return value of a function before returning it to the caller. So this way how the non-data descriptor helps you to intercept the function call for the instance method. Now we will see it for the class method. So here same way as the instance method, but when invoking the function, instead of passing instance, we will pass the owner, because we are looking for the class method which is stored in the class. So your class method will get executed, and here we are checking if the owner is not given as a none. If it is none, then we are deriving the class of the or the owner from the instance using type method. So here set interest rate is using this class method. So normally we are defining the class method using @class method constructor or the class method decorator. Here we haven't defined it, and because we are wrapping this using class method descriptor. So in order to demonstrate how the @static method decorator works, it works same way as this. So here we have passed this method to make it as a class method. Normally defining method this does not make it as a class method, it makes it as a instance method. Even though you have defined name as a CLS, it will be interpreted as a instance method. But when you are wrapping inside it and using either @static method decorator or you are using a descriptor which invokes function on the class instead of instance, it will invoke on the it will pass the first implicit argument as a class instead of instance. So it will resolve the class variable, and class variable value will be modified. So let's see with the example, or invoke and modify the value. So first we will check the type of the method after wrapping it. So it should give us as a descriptor function. So it is a type of a function, and if we try to modify value using this method, which is wrapped inside the class method descriptor, it should print this message, or the attribute access, method attribute access must be intercepted using this get method. So as we can see here, when invoking this method, it is printing this method, invoking this function with the given argument. So as args we have provided 4.8, and it has modified the class variable value interest rate using this class method with the given value. Now next is creating a descriptor for the static method. So for static method it is very simple, it does not take any implicit argument self or a CLS. So whatever the function we have wrapped using this descriptors init method, we are returning that function when it is calling. So it will intercept that static method access. So let's execute it. As we can see here, it is printing invoking static method with the given name, which is passed here as a static method constructor. Same will be stored as a function, and on attribute access of a get, we are returning just a function. So now we know the descriptor, we can implement a method same as a property which takes 3 or 4 parameters, setter, getter, deleter method, and we can set those function inside get, set and delete method. Now next topic is mixing descriptor and dunder for intercepting attribute access. So earlier we saw dunder get attribute, set attribute, delete attribute are also used for intercepting all of the attribute of a class. So what happens if we define both the descriptor also and override the get attribute method also? So when you are overriding get attribute, its default implementation on object class invokes the descriptor call inside it. But if you are overriding get attribute in your user defined class, and if you are not invoking any descriptor manually, then it will not call those descriptors. So you need to redirect those call to the object.get attribute. Otherwise, your descriptor in your class will not work. So when you are invoking any descriptor on your class, that attribute access will by default be intercepted by the get attribute method. Let's see it with the example. So here we have defined one descriptor object of descriptor G, which prints the message you are getting attribute value and you are setting attribute value from the descriptor method, and it is only bind to the one attribute only, amount, and it has also other attribute, instance attribute, and we have also defined get attribute, set attribute and delete attribute dunders, which will intercept the attribute access for the all of the attribute of a class, data and method attribute. So in that data and method attribute, the descriptor objects also come. So when you are invoking this descriptor on an object of a class bank account, the first intercepted for the, if you are getting the value, then first call will be intercepted by the get attribute method, and that get attribute method passes that call to the descriptor's get method. This is the default implementation of a object class. So in here we are just printing the message and passing that call to the get attribute of a object class. So which will ensure whatever the default implementation is inside the object class will get executed, and we will get to know how this call functionality works. So if it comes here, it will print the get attribute, and if it comes here, it will print the descriptor. Now let's create an object of this bank account and access the amount descriptor and see how the call of the function goes. So here we have setted the attributes of the object using init method. Now we will access the amount attribute and see the call hierarchy. So as we can see here, first when we are accessing amount, that amount attribute access is intercepted by the get attribute method, and then it is invoking the descriptors get method. So if we go to the code and see, this is invoked after the get attribute. So get attribute is calling this get method of the descriptor, and it is printing this message that getting the value of particular attribute, and it is returning that value of a attribute from the instance dictionary. So same way you can traverse using the class name, and inside the dictionary of a class you can access the descriptor object, and you can invoke the get method of this, so which will only invoke the descriptor's get method. Okay. Again you are invoking the amount inside the get method, so it will call the get attribute method of a class. So keep that in mind. If you are not using objects default get attribute in implementation, you don't override both get attribute also and use the descriptor also. So if you want to use both of this, then you need to pass that call to the object or invoke this particular descriptor manually inside this getter, setter and deleter method. Now we will see the difference between descriptor versus the intercepting attribute access using Dunder method. So descriptor can be applied as to the particular attribute, whereas get, set, delete attribute method intercept all the data and method attribute access, and descriptor method calls are made by the getter, setter and deleter method. So that is the main difference. So per attribute if you want to configure, then you can use descriptor. And if we compare descriptor and property, property is more flexible to configure or to intercept the attribute access, because you just need to pass those getter, setter and deleter method, and if you want to block access to the particular setter or deleter, you just pass none as a value, which will raise error by default. And for the descriptor you have to configure it manually by setting the set method and raising attribute error or the value error you want to raise manually. But comparing the descriptor and property, descriptor is a fundamental way of intercepting the attribute access, which is used internally by the property function. So property function is just providing abstraction over the descriptors, and descriptor has the more broader use than the property. Now next we will see the attribute access delegation when you are using object composition. So for example, if you are composing any object, so in this example car is having engine, so engine object is composed inside the car. So engine object is having its own data and method attributes, and if you want to delegate those attribute access inside the car object, then you can use get attribute method of object or the Python get attribute method. As explained earlier, you can access or you can delegate access to this particular attributes to this particular instance. So what happens is, if you create a car class object, and if you want to access the engine's method start and stop, then you can delegate those attribute access to the engine object, which is setted inside the constructor of a car. So even though the car is not inheriting any of these methods of a engine class, these methods are accessible using this getAttribute method. So let's see it with example. Here we have created car and engine object. So first we have created an engine, and that engine is set inside the car. So c1 dot engine will return the engine object. Now engine object is having start and stop method, and we want to access inside the car, and we have setted this getAttribute method which will delegate those attribute access to the engine object. So if we are invoking the start and stop function of the engine, it is accessible using this getAttribute attribute access delegation. Now one thing here to note is, when using delegation, special attributes such as string are not delegated by default. So here we can see string method is overridden by the engine, but car class does not define any string method. So that attribute access when printing the object is not delegated. So you need to define it using manually, or using inheritance or the mix-in class. So that brings us to the end of the video.